Good morning, everybody. My name is Athanasios Chassiakos. It's kind of Greek to you, but Nicola said it correctly. And I like to acknowledge the cooperation or actually the work of my colleagues Panagiotis-Tsikas and Rebeca Giavi. I guess that research on construction, on computing construction, is progressing well, but we in academia have another role and another responsibility to bring all this stuff to the young engineers, and I mean the students in the university. So this is the work that has been done as part of a diploma thesis in the University of Patras with the assistance of a BIM expert, because it's not easy to teach and to train young people in the detail of BIM. I don't think that I'm a BIM expert. I know several things, but I feel that I'm not an expert. So we need some experts. Following that, I'd like to say that the maturity level of BIM in Europe varies from country to country. This is a graph back in 2021. Things may have changed a little bit or more, but still there are countries that do it very well, and some other countries that are in the beginning of the process, and you can't see the Greek flag in there. We try to introduce the students in BIM and processes like that, and we like to do it not only for the basic project which is a building or something like that with rectangular elements more or less, but we like also to go to the infrastructure, to large infrastructure projects where perhaps the need for modeling these projects with BIM technology is higher than buildings. And lately, there has been the term I-BIM, infrastructure BIM, for projects that relate to infrastructure. And besides roads, which are very common, and bridges, the same, we are talking about dams, about tunnels, about railways, about ports, etc. And we like to make students understand and be able to work and make models, BIM models for such projects which have special difficulties compared to buildings. So we are talking about roads here. Such research has started a few years ago and goes on, and we like to go with the wave. So you can see here the various phases of the design methodology. First, we start with the terrain surface. We need to work on that, and then we put the main road elements, which include the road deck, sidewalks, roundabouts where it is needed, crossings, pedestrian bridges, etc. And of course, since we have the BIM tool, we have the 3D visualization of the project, and also we can add secondary items, secondary elements like signs, lighting, etc. As I said, this is the work of a diploma thesis, undergraduate diploma thesis. So we took a case study, a real case study from the city of Nemea in Peloponnese in Greece, where a new bypass road is currently designed, or it was designed a few months ago, started to design. And in the current situation, the road goes passes through the center of the city, and this creates problems in terms of congestion, safety, and things like that. And the municipality likes to have a bypass that goes outside the the city. There is a part at the end close to point 2, as you can see to the right, that it's kind of urban and urban area, and we need to do some things. The bypass is 1.4 kilometer long. It's going to be where the green line is. And one of the major things, the major issues is to connect the existing road with the new road, and in this case there are 2 roundabouts designed for such purpose, for smooth and safe traffic flow. And the design characteristics are the one that everybody that is working with roads, the design speed is 60 kilometers per hour, the horizontal radius more than or equal to 140 meters, and the maximum longitudinal gradient 3.8%. The road design comprises of 2 lanes, 1 per direction, with total width of 7 meters, and in the part that it is in the urban area or in the suburban area, there are sidewalks of width of 2 meters. So, major elements, the cross-section layers. For you that know about road projects, we have several layers. Starting from the bottom, we have 2 layers of some base, 10 centimeters each, another 2 layers of base, again 10 centimeters, and then we have the asphalt layers, 3 asphalt layers, and we need in between to place some coatings, adhesive coatings, so that the layers are connected to each other. This is an important part of the work, because these layers, these asphalt layers, the pavement in general, has not the same cross-section in terms of width. When you are close to roundabouts, you need to widen, and also in terms of the inclination, it's not something horizontal or with the same slope. So it needs some work, relatively more important and more difficult than other elements. Road lighting is another piece of the work of the project. In this case study, we designed 51 luminaires of 150 watt power, and also a road needs horizontal and vertical signage. Although this is not very difficult to design, you need to put it in the BIM model. There are other things, other elements that I'm not mentioning here. And one of the next directions in the BIM modeling is the cost estimation. The cost estimation, as in buildings, can be done in single elements or group of elements. You can see not very well the tables here for signs and for railings where necessary, and we can have the total cost estimate, which is 2.3 million for the 1.4 kilometer length. Some results of this investigation: the benefits are more or less the ones that everybody that uses BIM knows: project visualization, participant coordination, conflict detection, for instance in the drainage system, and parametric design potential. Of course, with the I-BIM technology, we can have efficiency in the project. and we can have life cycle management. Pavements, especially pavements, are the elements that have defects almost right after the construction or a little bit later because of the loading, of the dynamic loading. So we need a tool in order to manage the maintenance phase and in general the life cycle of the project. And of course, we can understand that I-BIM technology is a tool, a valuable tool for the design, for the construction, and for the management of such projects. Some conclusions. I guess some of us tend to believe that BIM technology is only for buildings. It's not true. We can use it for infrastructure projects. We can have 3D simulation at high level of information, which comes to virtual digital model, and then we can manage cost and time of the project construction, we can reduce waste, and we can improve in general the quality performance of the project. Saying that, I can inform you that we are interested now in other infrastructure projects, and I hope we'll do soon similar work for other infrastructure projects, especially for those that go further away from transportation, and I mean about dams and ports. Okay, I guess this is all. I hope I didn't spend more time than... okay, thank you.